This video is sponsored by PCBWay. Thanks, PCBWay. More of this later. Collaborations are always fun, especially when you're working with people who are great thinkers. There's one, of course, Richard from Learn Electronics Repair, whose brainchild this somehow became. When he approached me with that and said, okay, I got this load thing that can do USB, can we extend on that? I said, sure, let's do this. And it was a pleasure working with him, and all the ideas we threw around there and just build on each other. So this is actually a thing where you really can see two people working together to create something bigger, better thing, whatever. The other great partner as a sponsor of this video is PCBWay, because they provide us with all the PCBs we need. If you haven't figured this out, these PCBs over here are made by PCBWay, of course, and let me see if the camera can show you that. It's somewhat in focus, I hope. Please forgive me if it's not. I don't have a microscope over here. So always great quality to really affordable prices. We do this pretty early in production that we go to the PCB. And yeah, this is my modus operandi. I do things that way. So we were prepared to do a test run, test batch, and then build on that. Actually, this is still revision 0, I think. Which is a good thing, because normally revision 0 never gets as far. But maybe I should start at the beginning. If you have no clue what I'm talking here about, this is MultiLoad. It's a USB or elsewhere powered load, electronic load, that you can regulate to test, say, a power supply, something. There's an in-depth video on this topic over at Richard's channel, and I won't go into the details here because there's a video already, and Richard explains this perfectly. So while we were designing the thing, we had always the idea we wanted to have some kind of display on that, so we can control what's the voltage, what's the amperage, and of course, when you have voltage and amp, you can do watts. Pretty early in the design process, we included this little header over here. You see this, this has VCC, ground, and some current sense. We're grabbing the current sense down from the resistor down here, so we have it anyways. From there on, it was pretty easy what we wanted to do next. Well, crap, the microphone died on the recording, so this is an overdub. Yeah, we included this little display over here, and you see it shows the voltage, it shows the amperage, and it shows the wattage. And yeah, this is strange numbers. I'm using a very weird setup over here because I'm feeding this from a little hub, so there's the voltage drop coming from, and this doesn't really like any high currents. So you see the voltage is already going down. So this is probably what killed the microphone. So here's our little display unit thingy. It's a OLED display, and I designed the whole thing around the footprint of the OLED display. And you see there's all the magic happening. There's a little microcontroller. It's an AT-tiny 1614. I opted for this one because easy to use. We can program it by UPDI. And if you have no clue what UPDI is, there's a video on my channel telling you everything you need to know about UPDI programming. Very easy and very nice. The little micro over here has 16 kilobytes of flash, so I probably would need this. I knew I would need this because I wanted to have an OLED display, and OLED displays are notoriously, when it comes down to how many memory do they need. On the back side, there's a little voltage regulator, and actually we blew one up for science in the live channel. We needed to know what would the stress test here, so we fed it 30 volts, and it doesn't like this, believe me. 25 is fine, and since we're going for USB-C here, this is okay-ish because you only have 20 volts from USB-C normally. If you want to really go higher, you maybe want to change this or simply remove it. So here's a short update about this strange cube. I can't open this for the life of me, but while playing around with those LoRa gateways here, fascinating technology by the way, I came around with a spectrum analyzer because we have one around. And when I came close in contact with the cube, over here you see this, see the marker 1? This only appears when it close in contact with the cube. When I remove this from the cube, you see there it goes away. And when it's back here, it tells me this is sending something at 666 kilohertz. This is a bit obvious. I need to investigate more. But wait, before we jump into the software, let's have a short look at the schematics and the PCB in the editor. So this is my 3D view of the thing. You see two resistors, a little microcontroller, the UPDI interface, This is where the OLED screen will get mounted. By the way, there are OLED screens where SDA and STL is interchanged. You maybe want to have a look at this and buy the right one. Yeah, happened to me. Of course it did. So then here is voltage, ground, and I for current. So this is my interface to the main board. And if I turn this around, you see over here is a AP738E33. So this is a 3.3 volt low dropout regulator. We selected this one specifically for the maximum voltage. This can do up to 24 volts. We tried this with 24 volts and it gets about 60 degrees for a normal current part. This is nothing. The max 24 volts fits perfectly to our USB intent here, because USB PD can go up to, 20 volt. So we have much headroom there. From an electronic point of view, this is pretty boring. Of course it is. We have over here the OLED display with the connections I showed you before. There's a little voltage divider here that gets my V in, so this can be up to 25 volts, and breaks it down to a voltage that is suitable for the microcontroller. This is my connector to the main board over here. I need these two caps around the voltage regulator. The values are from the datasheet. Over here at the voltage regulator, nothing to write home about. Enable should be tied to VIN, so just simply tie it over there. And Vout produces 3.3. With a little microcontroller, there's nothing much going on there. 3.3 volts directly from the voltage regulator. Volts, current sense, ground, of course. UPDI is a programming port. And then we have these two. These are I2C interfaces. On an ATtiny, these are tied to special pins. You can swap them to different pins, but normally you use PB1 and PB0 for that. And of course, here's my UPDI programming header. Well, you can feed this with 5 volts, it wouldn't matter. 3.3 is the choice here, because we wanted to have some headroom to the 5 volt rail, and this way we're a bit more flexible. So there's not much to write home about. The Gerbers and all the software files you see in a minute will be all available as a download. I think Richard wanna set up a, a shared project on PCBWay. So you can have this downloading anywhere you want. And I share the source code anyways in the description of this video. So let's get over there and finally have a look at the software. Yeah, it's still 1.8.19 of the Arduino IDE. The big upside, I say this all the time, is that I can get you a complete package here. You have all the needed core files, you have all the libraries included, you download the portable installation from the description over here, and you go. There's nothing to set up, nothing to program in there or get a core that doesn't work. So as long as this isn't supported by the Arduino 2.something IDE, I'll stick to that. For me, there's no current reason to switch. Maybe IntelliSense, but this is a different story. As I usually do, I imagine we as a CPU and we're going through the software right now, so we can follow what the CPU will be doing while it's doing this thing. So as usual, we'll start in setup. The main attraction of the whole thing is the little OLED display. And for the OLED display, we need a library. So we include the perfectly done UHG2 library from Olli Kraus. I think he's a German like me. By the way, Olli, if you listen to this, kudos to the documentation. This is my perfect example all the time where I'd say, this is a perfect documentation. Everything is on the web. There's no guesswork. This works. And you can read everything up. I was playing around with some blah blah OLED for color OLED displays. I can't remember the name. And I went to so many hoops and red tape to find out how this works. Guys, I believe you. You're a good programmer and you're doing this stuff very good. But damn it, documentation is everything if people want to use this. Okay, enough of the rant. Let's see what we're doing here. So after including the UHG2, and it's in the IDE, in the download already, you simply create an object over here with the OLED display. This string over here needs to be set this way. There's a lot of thing going on. You maybe want to read up if you like. Maybe you don't. Probably you won't. And this gives me an object as it's called UHG2. Setup doesn't do lots. Setup simply sets the bus clock. You have to do this first before you do anything else. So we have a really fast bus clock here. We probably won't need this, but we have it anyways. Then we start the display. We set a font because we need to display some text. So I'll get some text over here. And this is probably the thing that takes most of the flash memory in this program because we have a big font in here. We could do something reduced things in there, but I need a V, a W, and an I. So I need some characters and I need numbers. So yeah, I'll include the full thing. You could reduce that, but there was no need. Some settings here, flip mode would be turn this thing upside down. Font mode is a color, I think, draw color. These are how the fonts get implemented and how it is displayed. This is the way it works. With these here, my display is set. That's all. I normally copy these things because if I reuse this, well, I've written this before, so I don't do anything here. And then I set my analog reference here to 1.1 volts. I'll do this because all the current measurements and the voltage measurements are built in a way that we have maximum 1 volts through the voltage dividers or through the current sensor resistors. If you get more over there, you have different problems, and they probably scream at you in a way that it makes loads of bad smells and explosions and fireworks everywhere. So this is a way to go. We measure internally against an internal reference of 1.1 volts in the little chip. Let's have a look what happens in the loop. And since you see, this is very short for me. This is only 64 lines with 20 lines of documentation. Whew. A very short program for me. So, yeah, laughable, I know. Draw display and wait for 100 milliseconds. I know I could have to put all the stuff in draw display in the loop. This is my thinking here. I'll need my functions. Sorry. So even the draw display function fits into one page. Wow, this is strange for me. Okay, let's play around with that. The main things over here is an analog read. And you see analog read and means enhanced, so you have more details in there. I think we can go up to 17 bits resolution with this. There's an extensive documentation in the core documentation for the 80 tinies from Dr. Azzi. The README for the analog functions is a bit wonky, I'd say. There's so much information and sometimes he gets carried away. He's a great guy and I love this project he did there. But sometimes this is a bit hard to follow. So what we do here, we simply get in UN16, so it's unsigned 16-bit value from the ADCs. So we get this for the voltage and for the amperage. Keep in mind, the voltage goes through the resistive divider. The amperage is a voltage that is measured over a 50 milliohms resistor on the main board. These values are naked values. You don't have any floating point in there because this is simply what the ADC sees. To get from the raw values, this is why it's called raw, to a really volts over here, we're doing this. Volts raw divided by V conversion fuck. Let's have a look what V conversion fuck is. This must be somewhere over here. There it is. V conversion fuck. Factor. Nothing else. Get your minds out of the gutter. And yeah, you see, these must be floats somewhere, 246.6. How did I came up with these numbers? Well, I could tell you that I did some magical math over here and came up with this. You know, I grabbed a multimeter, simply measured the voltage that is coming into the thing, and calculated the conversion factor from there. Because I could see what the raw ADC was showing me, and then I knew this must be 5 volts. So I did some measurement points. I measured 5 volts, I measured 9 volts, measured 12 volts, 15 volts, blah, 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 all the thing a USB PD could get me. And from there on, I did a mathematical sum of this, get the medium, and this is what came out. Is this on the same quality as a good multimeter? No, for real it isn't. You can spend much time there tweaking this. This is the lazy way. Of course it is the lazy way. And you know, for a very brief overlook, how much current, how much voltage you have there, this is fine. You only want to have something, well, I'm not going to say in the ballpark, well, I just stated. For better detail, for higher resolutions, for a more consistent thing, you maybe want to put on a separate voltage meter. This is more for having a look, okay, saying this is 9 volts and we're drawing around 40 watts. This is the way to do this thing here. So after this conversion over here, as you see from there, we have volts in a float. And I do the same for the amperage over here, of course. And watts is, of course, amps per volts. So, yeah, math is done after this. Then I built some strings. Yeah, I know, strings. String class takes lots of memory and is horrible to work with. Bear with me, guys. I like my string classes, and it's easy to draw them. I can do simply concatenation here. I go volts equals and then put a string after that. It isn't getting easier. And I won't spend much time to doing a char array and doing the blah, blah, blah. And not me. Sorry, this is the lazy way to do that. So after this, we have 3 strings, V, A, and W. I know this could be longer variable names. You could say something like voltage as a string for the display, blah, 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 blah. Wouldn't help me because I'm only using this string inside this function. This is not global. This is not static somewhere. This will get used right after that. And we're using them down here because this is how you write to the display. So I can live with short variable names because they're used right around the corner. If I had something that I need to transfer into another function, I would use a more descriptive variable name, but for this, no way. So writing to the display is pretty easy. Clear the buffer, then I write my voltages and the numbers over here. Let me just do the thing here. And the numbers over here is a coordinate. This is left bottom of the font. So 0 is on the upper left corner and 13 pixels down is where you start the thing. You need to have this in mind while you're writing this. And there could be underlines, underlings. I don't know how this is said in English. So 13 would be the underline of an A, I think. And if it is a G, that would be 2 pixels further down, something like that. So you can tell I draw my voltage over here. This is the voltage thing. And I draw this there, then I draw my amperage. This is right below this, so this would be 26 pixels down, and it's a 0 coordinate. And then I go to the middle of the display, 64, and go for 13 for the wattage. You think this is ugly? Maybe it is. I don't know. But this is the beauty of it. Change it. So one thing you shouldn't forget, send the buffer after you did the drawing, because if you don't send the buffer, it never gets displayed. Ask me how I know. So this is the whole shebang. There's nothing more in here. Draw display does this. And from there on, let me have a look in loop if I forgot something. This is scroll down. Yeah, it is. Yeah, and from there on, I simply wait 100 milliseconds. If the display is too fast for you, simply turn this down a bit and Bob's your uncle. So this was a more short video, and this is more the add-on, the follow-up to what Richard did on his channel. I really like this format where we split our parts in the corporation and show different parts of the thing. We have different styles to explain stuff, and we have different focal points. So I think you guys participate from that. Let me know what you think about this. I'm really interested in that because we fine-tuning our setup all the time, and the collaborations will happen in the future. We are working on stuff right now, and I messed really up with the AT Extra, but this is for a different video. Again, let me thank PCBWay, the sponsor of this video, for being with us. Well, they're great people over there. They are really supportive. When we have a question, they answer very, very fast. And don't forget, they did the assembly for the little boards, for the display boards. We, of course, ordered some naked boards because you want to have some naked boards. If you want to try something out there, it's always good to have some naked boards. But we ordered them assembled. So this is a great service if you don't want to spend the time, or maybe it don't have the abilities to solder, say, some SMD parts. These days, some of the really fancy voltage regulators are only available in SMD. So you can't even do this little SO253, I think, is it? For me, this would be at a point where I'd say, do I want to do this? I probably can. But if I have to solder, say, a bunch of them, say 20 boards or something, I would get mental. No, thank you very much. And don't forget, you don't have to source all the parts yourself. They do this for you. This is a turnkey thing. So you simply tell them, I want to have AP blah, 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 and an AT tiny on there, and they order this stuff for you. You don't have to have this lying around somewhere in your apartment. And remember, when you order stuff like from DigiKey or Mauser, this is expensive because you get shipping on that. With AliExpress, you could get a fake product. So remember, this is a great way to have access to all the parts that are out there without having a separate room full of electronics like I don't have. No, I really don't. This is it from me for today. I hope you enjoyed this short deep dive. Well, didn't feel like a deep dive. There are more complicated things coming up. I really enjoyed working on this project with Richard. And yeah, as I said before, there will be more projects like that. Expect some madness. I hope you learned something and have a great day. And I'll see you around, guys. Bye for now.